Hello, this video is for the Tuna Cam Stage 1. So it's our bottle opener and we're going to do Stage 1. And it's going to primarily be setting up our stock and then setting up the first about 3 tool paths. So let's show you real quick what I'm talking about. So in Fusion 360, this is our stock right here, this yellow kind of weird box. And then we're going to set our work coordinate system, so our x0, y0, z0. And after we get this all set up how we want, we're going to do a face mill pass, a drill, and a drill. And we're going to call that stage 1 because as you see, I have a whole lot of tool paths here. So I don't want to have a bunch of million minute videos. I want to keep it relatively short per video, not too overwhelming. So the first thing I want to do, this is my completed one, is we need to set up the stock. So when I refer to stock, I'm literally talking about the aluminum stock that we're going to we're going to start machining with. So in this case, we're going to cut, these are our saw cuts. I don't know how clear you can see it. We're going to make it in the X dimension 3.75 inches long. We're going to make it 1 inches in the Y and 0.625 inches in the Z. So that's 5/8, 1, 3 3/4 if you want to use some fractions. And what does that represent? So that stock, this stock in my hand represents this ugly yellow box right here in Fusion. That is exactly what we need to create first. So this is my completed one. Let's flip on over to where I would have left you off in my modeling. So before you get started, you could go ahead, you could save a different version or continue working off of your version. I have several versions. This is my cam for instructional videos, so I saved it separately. Generally in Fusion though, you want to keep all your designs in the same file and then build your cam off that design. I'm just going to have a bunch of kind of separate files. But here you are. You finish your modeling, everything works great. We're in design environment. So from design, I need to hop on over to manufacture, and this is where we can set up our stock and our tool paths. So this is our cam. Let me make sure I don't have a setup right here. Oopsies, do I? Let's go. The first thing I'm going to do is I'm going to go setup, and I'm going to say new setup. And I want to come over here. If your X, Y, and Z are oriented like mine, so whenever I set up Fusion in the modeling, like it should be how mine was, where if I'm looking at the top of the view cube, I have Z up, X to the right, Y away. It's like I'm in a 3-axis milling machine looking down at my part. So the top view has the most features usually that I can machine from one operation. And if your work coordinate system, the WCS, your XYZ, if it matches mine right now, where the Z is up, X is going to the right, and Y is going away, then I'm just going to hop on over to my stock. Now, hold on. If it wasn't set right, you can force it to how you want. So you'd go to orientation, I could go select Z axis, and then I could force what direction I want my Z. And if the X and Y are still not going the right direction, this says Z axis and X axis. So I select my Z. I know I want my Z up. And then I would define my X axis as well. But mine looks all pretty, so I'm going to hop on over to stock. And for mode, I want to do a fixed size box because we're starting with a fixed size stock that I cut on my saw. And in the X dimension, I want 3.75. I want the model position center. Y, I said in the Y direction is 1 inch. And the thickness of my stock is 0.625. So this is just standard aluminum I can go and get at the store at the local metal supplier where I live. It's a real common size. And here's where we got to start paying attention. You see, when I have my height and my Z, it automatically keeps, this is the model, it's the actual model, the connecting, or the bottle opener. Sorry, I've got a lot of projects on my head, so sometimes I get the wordage mixed up. But this is our tuna bottle opener. Now, I want the model positioned at the top of my stock. So check this out. I have, oopsies, let's see if I can change my screen. Apparently I'm looking at the wrong one. That's cool. So the way this is machined out is I have the model positioned at the top because I want to elevate everything in my vise. And I'm going to have it sitting on parallels. We're going to use 1.625 inch tall parallels that are 1/8 of an inch wide. So it's a typical standard tallest parallel in a parallel set in your common parallel set. And I want my model, that little bottle opener, to be at the top. So that way I've got extra material to grab down here because the vise is going to clamp on with the tallest parallel about 100 thou. It's about 110, 111 thou. So I want to be safe. I want my model at the top. So what I'm going to do is model position. I'm going to say positive Z, and we're going to offset this thing by 20 thou. I'm going to say 0.02. So I'm leaving a little, you couldn't see that. So what I did was model position offset from Z positive, and then I updated 20 thou right here in the offset. And now we're on the same page. So I want to leave a little material because I'm going to cruise down with a face mill and skim off that extra material. Now, our work coordinate system, we're determining how we're going to actually locate our work piece. So in this example, I could leave it in the center, especially if you have a probe. You can look like probe on each side and then get your center. Even without a probe, it's usually more accurate to have your work coordinate system in the center. So in case your stock changes a little bit in the X dimension or Y dimension, it's still centered. However, to keep things easy, we're just going to put it, which is also a pretty common practice, is we're going to put it on this back left corner. So I'm going to go to setup, and I want to choose a stock box point, and it's literally talking about a stock box point. And I'm going to see my stock box is highlighted in blue. And when it's like that, I'm going to come over here and click on this point. So this means when I'm using my edge finder, we'll use a wobbler edge finder in this case, or a Heimer. I'm going to touch this off of my X, my Y, and the top surface will be my Z0. So if I look at the front, this is my Z0 reference plane, and the X, this is my saw cut, and then this ends my saw cut, which I typically want to avoid clamping. And this is my Y, the part that's going to be resting against my dead jaw. That is how we're going to set it up for this one. Makes it nice and easy. So, okay, there we go. We have set our stock with our model inside of it. Beautiful. The first thing I'm going to do is I'm going to do a face pass. So I'm just going to deck the top off, make it nice and smooth and a flat machine surface to work from, get rid of any surface imperfections, anyone dropping it off of a forklift during shipping, whatever. I want a nice clean surface to work with. Not every application needs to be faced, by the way. How am I going to do this? I'm going to go up here to 2D, and I'm going to go face. And for my tool, I'm going to come up here and click on here. Now on my website, I have my tool library posted, and this is the clay mini mill aluminum. And now I try to set this up the best I could for the time being using the exact same equipment that I'm using. So for my face mill, I have a Mari tool. It's a shell mill. It's a 45-degree shell mill. The icon you're going to see is not super representative of it, but it's going to work well enough for this application. So yes, this needs work. If I get enough traffic, then I'll make it look more pretty. But right now, we're going to deal with it. The other ones I have, they're Haas, so this is a whole entire Cat 40 tool holder. This is a cutter that I'm using. I buy a lot of the Haas tooling, and I'm not sponsored by anyone at all out of my own pocket. The Haas tooling is super affordable. They've got nice feeds and speed charts. And this, going back to my Mari tool, it is typically a little more expensive than Haas tooling, but I love it. This cutter, or this shell mill I got and tool holder, it's awesome. I love it. It cuts really well. And boom, boom, boom. These are all my tools. Anyways, we're gonna do tool number 1, which is gonna be my shell mill. So I'm gonna say select. And I already have, it should have my parameters defaulted in here. Spindle speed 6,000, ramp spindle 6,000. And this is chip load based on my cutting feed rate, which is 30 inches a minute, 30 inches, 30 inches. And I've already ran these, so I kind of know what to expect. Now, Geometry, I'm not going to select anything. I'm just going to leave this default outline. I'm on my heights tab. Now my top height is my stock top and my bottom height is my model top, meaning that the lowest my tool is allowed to go is my model top. So this one would be your stock top, this kind of weird blue, and this darker bluish purple would be your model top. So that's it says, all right, the tool cannot go past the model top because that's where we want it to stop, right? Passes tab, pass extension, it's pre-populated, which is pretty cool. It looks at your cutting diameter and then just it divides it by 2 and tacks on a little bit of extra, so that way your shell mill comes all the way off the part before lifting. But just for fun and just so you know what oopsies, my cutter diameter is 2.48, divide 2 equals 1.24. And if we see, here's 1.24 and an additional 4,000. Let's just say 1.3 so I know everything's all the way off and I don't have these weird numbers to work with. I'm not going to adjust anything on my linking tab and I'll say OK. And here you can see the face mill. I don't have the tool body on here, but here we go. It's going to come in, it's going to sweep down, cut, come all the way off, and then go up. And if you wanted to, you can go Actions, Simulate, and you can run this bad boy through your simulation. Let's get it so we can see a little bit. And I can say play, and it's just going to keep rerunning. So there we go. We simulated it. We're geniuses. We got it. Now the next toolpath. What I'm going to do is, I know in the future, I'm going to have to flip this part over and machine the back side. So this is a completed top operation. I'm just holding it in a vise, machining everything out, but I somehow need an easy reference point when I flip it over to machine out the back side, because you know, I don't have, it's not a square surface, which we still could work around that. I do have a square surface here, but it's really easy to just have a bore in something that goes all the way through, flip it over, probe, pick up that bore, and then that's for your X and Y location. And then Z, I'm going to place Z at the bottom of it for a real accurate part. But I want to have a bore going all the way through. And another thing, when I'm coming into these tight corners with an end mill where the radius almost matches the same radius as a part geometry, there's a whole lot of stress on that cutter, a whole lot of engagement. So that's a lot of times where you'll see chatter or where you'll see tools break because of real tight geometry. So I'm just going to relieve those holes. I want to pre-drill this hole, so I'm just going to go ahead and drill this one too. Not always necessary, but my drill is far more efficient at going vertically down than my end mill is. So I'm just going to do that just to try to minimize problems. And I know in the future I'm going to pop a big hole all the way through this one. And I want, when I'm coming down in a helix with an end mill, I want a little hole down there so the chips have a place to go through. So when the coolant's washing it, it can blow out the bottom and there's less likely chance I'm going to weld up my end mill. So that's kind of my mindset on here. The next one I'm going to do is drilling. I'm going to go drill. And I'm going to go to my tool library. And I'm going to go to my clay mini mill. And you see right now, it kind of filtered my tools. It only shows this one. Sometimes that can be helpful. Sometimes it can be annoying. Right now it's helpful. But if that gets in your way, you can clear your filters and it shows all your tools. But I do want to use my 1/4 inch, where is it? Tool number 6, my 1/4 inch, just a high-speed drill, screw machine drill. Yes, I don't know why I'm drawing a blank. All right. And I think these defaults are going to work well for us. I have it at 3,500 RPM at 10 inches a minute. And these parameters are, again, I have them for a mini mill 1 with a standard spindle on it, so nothing crazy on here. If you got a smaller machine, you're probably going to have to reduce my feeds and speeds. If you have a bigger machine, you're probably going to have to increase my feeds and speeds. So for geometry, we're going to select right in here. I'm just going to come in and select on that face. And then I'm just going to select on this face. And here we go. I have those selected. And let's go to heights. And as you saw on here, one of those holes go all the way through and the other does not. Sorry, someone rang my doorbell and it's just kind of annoying me. Now I'm not thinking straight. So that drill does not go all the way through because I don't need it to, but this one I prefer it to since I'm coming in there and doing a big helix in. So let's not look at me. So for bottom height, actually, I'm probably going to do this in two different operations because I'm going to come back here to geometry. I'm going to clear that out. So if I selected something I don't want, I just hit that little X. I'm going to come here. I'm going to select there. Heights, I'm going to say stock bottom. If I can read here, stock bottom. And I want to drill the tip through bottom. And I'm going to go through an additional 20 thou, 0.02. So that way I'm drilling all the way through and I'm making sure, because sometimes when you poke through the bottom of a drill, it leaves kind of a heavy burr. So I'm going to go through just a little bit. And for cycle, we'll just do, to be careful, we'll do a chip breaking and we'll do partial retract. So I'll go down 300 thou before I have a partial retract. So I'll say 0.3. And I'm going to say OK. And just so I didn't mess anything up, I'm going to look real quick at the other one I did. Yeah, so that all looks the same. I shot through the bottom. I know this all works, so I'm just kind of double checking so I don't lead you all around incorrectly. So on this one I did a 0.25 pecking depth. So I'm just going to, if I don't crash it, I'm going to leave it. 0.6 is totally, or 0.3 is totally fine. Now I want to create another drill toolpath, but I don't need to drill this deep again. So I'm going to right click and say duplicate. And now I have this exact same toolpath again. So I'm just going to edit it. I'm going to right click and I'm going to say edit. And now I have this little dialog box here. And we already showed you how to screw up and deselect stuff. So on geometry tab, I'm going to clear out that face. And I'm going to select this face right here. And for heights tab, instead of stock bottom, I'm going to say model bottom, because I'm really just relieving that tight area. So when my 1/4 inch end mill comes in here, it's not trying to create chatter and it's trying to reduce all that engagement. So I'm going to say model bottom, drill tip through 20 thou, leave everything the same. So it just pokes through the bottom and I like it. And I'm going to say okay. And there we have it. So there's my through hole. Here's my hole that does not go all the way through. And if I want to run graphics, I can go like this, actions, simulate, and then I can run it all the way through. And that is it. I'm going to say exit simulation. So this concludes stage 1 of the Tuna CAM. And I will see you for stage 2. Thank you.